Hello students, welcome back to the lecture number 2 in discrete random variable, right? We'll see the today's question. Let capital X denote the number of heads in a single toss of 4 fair coins. Determine P of X less than 2 and P of 1 less than X less than 3, right? So what is mean by X here? Here X denoting the number of heads, and I'm tossing here 4 coins only once, because in my question it mentioned in a single toss of 4 fair coins, right? Now we should know, when tossing those 4 coins, what are the possible outcomes? Do you know what are the possible outcomes we will get? And do you know how many possible outcomes we will get? Yes, we will get 16 possible outcomes. So what are the 16 possible outcomes? What are those? Let's see now. See, these are the possible outcomes I will get when tossing 4 coins once. See, first possible outcome, second possible outcome, third, fourth, and fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th. See, these are the 16 possible outcomes we are having when tossing 4 coins once. Okay, now coming to the solution. So, what is mean by X here? X is denoting X is denoting the number of heads. X is denoting the number of heads, right? My question, in this first possible outcome, in this first possible outcome, how many heads you are having? How many heads you are having? Only one head you are having. Similarly, second possible outcome, 2 heads you are having. And in third possible outcome, there is no heads, so means 0. In the next outcome, 1 head we are getting. And similarly, here 2 heads, 3 heads, 1 head, 2 heads, 2 heads, 3 heads, 3 heads, 4 heads, 3 heads, 4 heads, 1 head, 2 head, 2 head, and 3 head here. So it is nothing but the conclusion of this given question. X denoting the number of heads. So how many heads is denoting here? X is denoting the number of heads are 0 times, 1 time, 2 time, 3 time, 4 times. Okay, so that is mean by the X here. 0, 1, 2, 3, and 4. See, these are the random variables of X. Okay, then what will be the value? What are the probabilities for this random variable? See, 0. 0 is nothing but there is no head getting, right? So out of 16 times, how many times I'm not getting head? Only once I'm not getting head, right? So can I say the probability 1 out of 16 times? Yes. So now getting one head, how many times I'm getting one head? Let's count now. See, 1, 2, 3, 4. See, there are 4 heads I'm having in this possible outcomes, right? So how can I write the probability? 4 by out of 16 times. Now how many times I'm getting head is twice? Let's count again. 2, 3, 4, 5, 6, 7, Just a minute. I will recount it. One, two, three, four, five, and six. Right. See, there are six times we are having two heads. So what is the probability? 6 out of 16 times. Now, similarly, how many times I'm getting three heads? Let's count now. Once, two times, three times, four times. See, I'm getting three heads four times. So it is nothing but four times I'm getting out of 16 possible outcomes. And similarly, how many times I'm getting four heads, that we know. See, how many times I'm getting four heads? Only once I will get, right? So this is the possible outcome. See, getting only once four heads. So I can write the probability 1 by 16. See, now we'll call it as this is the distribution function table. Okay, right. So we need a table. Now the table is came to us. Let's solve the solution of the first question. Okay, right. First question. What is the first question? P of, what is the first question? P of x less than 2. So it is nothing but x less than 2. So what are the values of x here? Below 2, right? So can I say x taking the values 0 and 1? Yes. So x taking values are 0 and 1, so which is nothing but, how can I write here? I can write it as p of x equal to 0 plus p of x equal to 1. Okay, so this is the way I can denote it as when p of x less than 2. Now what is the probability at x equal to 0 in the table? See, 1 by 16 is the probability, right? So I can write here 1 by 16. Okay, right, plus at x equal to 1, at x equal to 1 here, what is the probability I'm having? 4 by 16, 4 by 16. Then by adding these two, I'm getting 1 plus 4, 5, 5 by 16. See, this is the probability of getting, this is the probability when p, p of x less than 2, right? So now we'll go to the second question. P of 1 less than x less than 3. P of 1 less than x less than 3. So what are the values of x here? X value is taking above 1 and x values are taking below 3. So above 1, below 3, which is nothing but, can I say the value of x is only 2? Yes. So we can denote here, which is equal to p of x equal to, we can say here p of x equal to 2. So at x equal to 2, what is the probability in my table? 6 by 16. Yes. So 6 by 16 is the solution. Okay. And this is the probability at 1 less than x less than 3. Right. I hope everyone is clear to you. Now we'll go to the next question. Right. What is the question here is asking? A random variable capital X has the following probability distribution. See, I forgot to I forgot to tell you one thing. See, In this discrete random variable, there are two different questions we are having. Can you guess what is mean by the two different questions? Yes. So one question, one type of question does not containing the table. In my question, he won't give you the table. That is one first type of question. Okay now. And second type of question, table will be given. Okay. See, in this question, table is given you. So now he wanted to find just k value and p of x less than or equal to 2 and p of x less than or equal to x less than or equal to 2 less than or equal to x less than or equal to 5. Okay. Now we'll go to the solution. Right. So what is asking in the first question? Find the value of k. See, whenever he is asking to find a value of k, we have to take the help of second property of discrete random variable. What is the second property? Did you remember? See, this is the second property of discrete random variable. I told you when I explained this definition, p of x is a discrete random variable. When do you say p of x is discrete random variable? If it satisfies these two properties. Yes or no? Yes or no? Yes. So in this question he is saying that p of x is a discrete random variable. So if it is discrete random variable, it is satisfy these two conditions. Yes or no? So now with the help of second property, I am getting the value of k. Okay, right. So we know that summation I equal to 1 to n p of x equal to 1. It is nothing but, can I say, sum of probability. See, these are the probabilities. K, 2k, 3k, 4k, 5k, 6k, 7k, 8k are the probabilities. Okay, right. So summation in the sense adding the probabilities. So we will get k plus 2k plus 3k plus 4k plus 5k plus 6k plus 7k plus 8k. It is equal to 1, right? So now add this all. 1 plus 2 3 6 10 15 21 28 and 36, right? So 36k is equal to 1. So therefore what is the value of k? It will become 1 by 36. Okay, so 1 by 36, it is approximately 0 point something. Yes or no? K value. Okay, something 0 point something, I'm getting the value of k. If I substitute this k value in this probability, will I get p of x greater than or equal to 0 condition? Will I satisfy this condition or not? Yes, we can satisfy this probability, this condition. Yes or no? And this is the first property of discrete random variable. Yes or no? Right. Okay, so now coming to the second question. What is asking? P of x less than or equal to 2. So it is nothing but, what are the values of x? 0 and 1 and 2. So it is equal to p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2, right? At x equal to 0, what is the probability? Yeah. So okay, fine, very good question. This is in this table. Do you have x value 1? No, right? So which is nothing but x won't take x equal to, x won't take 0. Okay now, right? So I'm removing it. Very good question this is. So which is nothing but x can take only 1 and 2, because in the table I'm not having 0. Yes or no? Okay, right. So at x equal to 1, what is the probability I'm having in the table? Tell me. K. Plus at x equal to 2, what is the probability I'm having? 2k. Yes or no? 2k. Then by adding this I'm getting 3k. So which is nothing but 3 into k value. I got 1 by 36. Yes or no? So then, so what will be the solution? 3 ones are 3, 12s are. So it will become 1 by 12. So means means I got p of x less than or equal to 2 is equal to 1 by 12. Yes or no? Right. So now we'll find the third answer. What is the question? 2 less than or equal to x less than or equal to 5, right? So p of 2 less than or equal to x less than or equal to 5. So it is nothing but, so what are the values for x in this question? X taking 2, 3, 4 and 5. Yes or no? Right. So it is we can denote it as p of x equal to 2 plus p of x equal to 3 plus p of x equal to 4 plus p of x equal to 5. So at x equal to 2, what is the probability I'm having in the table? 2k. Yes. So 2k. And at x equal to 3, I'm having 3k. At x equal to 4, 4k I'm having. At x equal to 5, 5k I'm having in the table. Yes or no? See. Yes. Right. Now, so we can add this. 2 plus 3 5, 5 plus 4 9, 9 plus 5 14, 14k. So what is the value of k we had? Tell me. 1 by 36, right? So this is the final answer. I can cancel, right, in the 2 table. So 2 sevens are and 2 18s are. So 7 by 18 is the probability of getting 2 less than or equal to x less than or equal to 5 heads. Okay now, right. So this is what my solution of third question. Okay, so we'll meet again in the lecture number 3.